Hi, welcome to the talk on our paper, Face, Body, Voice, Video Person Clustering with Multiple Modalities. I'm Andrew Brown from the Visual Geometry Group at Oxford University. In this work, we're focused on the task of video person clustering. This is the task of grouping all people in videos by identity, where the test identities are not seen during training. The goal is shown in this example video, where the bounding boxes around each person are labeled by identity from the algorithm. Person clustering has many interesting applications for person-centric video editing and understanding. For example, it enables character-based video navigation, allowing you to fast-forward to a scene containing a certain set of characters. Alternatively, it could be used to automatically collate highlight reels, showing, for example, the interactions between specific characters. Person clustering can also provide us with some basic level of storyline understanding. The person clusters can tell us the proportion of the total videos that pairs of characters co-occur in, shown in these matrices. This gives us a basic idea of the storyline by telling us which characters' interactions are given the most screen time in that particular episode. This is interesting when contrasted across multiple episodes, as shown here, which gives us an idea of how the storyline changes. Previous approaches to the task have focused on face clustering. This ignores all people without faces in the scene, limiting its use for the applications we just discussed. Our method instead clusters all people by moving to a body representation of each person rather than just face. We also harness all informative cues for identity by using different complementary views of each person instance from different modalities. Specifically, we use deep discriminative representations from face, body, and voice. In this work, we first present a multimodal high-precision clustering algorithm for video person clustering. We secondly present a video person clustering dataset for evaluating multimodal person clustering. Our multimodal high-precision clustering algorithm proceeds in 3 stages. Here are all body tracks for a character in a video. In stage 1, a hierarchical agglomerative clustering algorithm is used to overcluster with high precision using the face modality, which is more discriminative than the body and voice modalities. At this point, the face modality alone cannot be used to reliably discriminate any further. In stage 2, the complementarity between face and voice is used to bridge clusters of the same identity via speaking faces in each cluster. Lastly, faceless bodies are merged to clusters using nearest neighbors from the body representation. Our second contribution is the video person clustering dataset for evaluating the task of multimodal person clustering. This dataset contains body tracks for each annotated character, face tracks when visible, and voice tracks when speaking for the characters in 6 diverse movies and TV shows from over 23 hours of video content, making it the largest dataset of its kind by some distance. It contains all associated features from each modality. We're the first to report results on the task of person clustering on the video person clustering dataset, so we compare to strong baselines. Here we show the strongest baseline in the paper, which uses information from the body and face as shown on the x-axis. We compare to 2 versions of our method here, one using the information from the face and body, like the baseline, and our full method using face, body, and voice. We measure weighted cluster purity and normalize mutual information for measuring the cluster quality. For both, higher is better. The interplay between both of these metrics is important to demonstrate that high precision is not attained by simply just overclustering the dataset. Our face and body method outperforms the baseline significantly on both metrics. Our full method retains the high precision while adding another significant boost to NMI. This highlights how our method focuses on high precision, but class overlap between clusters is still reduced via the multimodal bridges. We also outperform all prior works on face clustering datasets. Please see the paper for further details, ablation studies, and the story understanding analysis. Let's now look at some qualitative results. In the following video, note how each character is labeled with their own unique identity cluster by the method, in challenging poses, in the background of shots, and when viewed from behind.
Hi. Hey. Ooh, Phoebe, you look great.
How bright already.
Ooh, are you gonna do magic?
That's funny. Changed.
Hang on a second, I just got in.
Look, I don't care. It starts at 8. We can't be late.
We could not, would not, want to wait.
Look, our table is down in front, okay? My boss is going to be there. Everyone will see if we arrive after it starts.
Thank you for listening. Check out the project page for further details and also the datasets.